Hello and welcome to Sleepy Scientist. I'm glad you're here. Whether you've had a long day, a busy mind, or you simply love falling asleep to the sound of science. Tonight we drift beyond our pale blue planet through the velvet silence of space, where rusted winds sweep across a lonely ancient world. The sky turns a soft butterscotch as dust rolls in gentle waves over canyons and ridges. You hover just above the surface of Mars, feeling the chill of its thin, quiet air. And below you, like a sleeping colossus, stretched across the planet's skin, rises something truly extraordinary. A mountain so large it would cover the entire state of New Mexico. So tall that it brushes the ceiling of Mars's atmosphere. So massive it changes the way light curves around the horizon. Tonight we explore Olympus Mons, the tallest volcano in the solar system. If you enjoy these sleepy explorations, I'd be so grateful if you gave the video a little like and tap that subscribe button. It helps more sleepy scientists like you find their way here, and it means I can keep making more of these journeys for you now. And now let's gently begin. You let yourself drift light as a whisper above a copper-hued world. Below, canyons yawn, and boulders rest like forgotten thoughts. But there, toward the western edge of a sprawling bulge in the Martian crust, called the Tharsis Rise, you see something that defies your sense of scale. It's Olympus Mons. And it doesn't just sit on the surface, it owns it. You squint slightly. The base of the volcano is 370 miles, 600 kilometers across, wider than the entire state of Arizona. That means if you stood on one side, the summit would be far beyond the curvature of the planet. You wouldn't even be able to see it. And its height, breathtaking. 13.6 miles high, or about 72,000 feet. That's nearly 2.5 times the height of Mount Everest. You ask yourself, how is that even possible? And right there in that question, the journey begins. Because Olympus Mons is no ordinary mountain. It's the result of billions of years of volcanic artistry, a sculpture in slow motion. Not jagged and craggy like the volcanoes you might imagine on Earth, but smooth, spreading, almost gentle in its slopes. It's what geologists call a shield volcano, shaped more like a warrior's shield laid on the ground than a sharp cone. If you were to stand at its base and begin walking to its peak, the incline would be so gradual, just 2 to 5 degrees, you might not even realize you were climbing. It would feel like a gentle uphill stroll, not a death-defying ascent. But don't let that gentle slope fool you, because the sheer volume of Olympus Mons is staggering. Scientists estimate it contains 100 times more material than Mauna Loa, Earth's largest volcano. Imagine the effort it took to push all that molten rock skyward again and again across the ages. And it gets more curious. Olympus Mons doesn't just rise, it casts shadows on our understanding of what planets can do. Its formation required a combination of factors that Earth simply doesn't offer. And so, over the next few sections, we'll peel back each layer one by one. But for now, just stay here, drifting slowly above it. Notice how the volcano's edges are lined with steep cliffs, some dropping off for several kilometers. They're called scarps, and they form as the weight of the volcano presses down, creating collapses around its massive base. The mountain is so large, it actually sinks the crust beneath it, like a ship pressing into soft clay. From above, it resembles a sunflower pressed into sand. Wide, round, and rippled with lava, flows that cooled into winding textures like long-forgotten brush strokes. And then there's the summit. Not a single point like Everest, but a caldera, a wide, collapsed crater formed when the lava chamber beneath emptied and the top of the volcano fell in. Olympus Mons has 6 overlapping calderas, each the result of different eruption events. The largest of them is nearly 50 miles across. You could fit an entire city inside it. A place that big, that tall, that quiet. It doesn't just form overnight. It takes patience. A slowness beyond human years. And Mars has always had time to spare. You begin to wonder what made this place grow to such extraordinary heights. Why doesn't Earth have a volcano like this? Mars is whispering now, and we're going to listen. Not all at once, not in a rush, but slowly as the red dust shifts and settles beneath us. Let Olympus Mons introduce itself, first silently, proudly, timelessly. Then we'll begin to uncover how it came to be. You keep floating the summit of Olympus Mons, gently turning beneath you, like the hour hand of a clock that has long since forgotten how to tick. The Martian sky above is dusky and thin, a faded caramel dome brushed with the barest outline of Phobos Mars' haunted little moon skimming across the heavens in an endless loop. Below the mountain waits vast, ancient, and still. You tilt downward, curious now, not just by its size, but by how it got that way. You already know Olympus Mons is the tallest volcano in the solar system. But why? What secret ingredient made this giant rise while Earth's volcanoes stay short and sharp? You descend toward its slope, touching gently on the reddish ground that feels like powdered iron and talcum. The ground doesn't quake beneath your steps. Mars is quiet. Always has been. And here's the first clue: gravity. Mars is about 1/3 the gravity of Earth. So if you weigh 150 pounds on Earth here, you'd feel as light as 50. Your steps would barely scuff the dust. And for mountains, gravity is more than just weight. It's a sculptor. On Earth, gravity works against volcanoes. The higher they grow, the more stress is placed on their own foundations. Eventually, the rocks buckle, the flanks collapse, and their growth is capped. But on Mars, gravity is gentle, forgiving. Lava can pile higher and higher and higher without being crushed by its own ambition. You might imagine Mars's gravity as a soft-handed potter, letting Olympus Mons rise like a dome of dough, unhurried without caving in on itself. And the result, a volcano nearly 22 kilometers high, something utterly impossible under Earth's stronger pull. Then, as you continue down the slope, your thoughts begin to stretch. Lower gravity isn't the whole story. Other planets like Mercury or the Moon also have weak gravity, but they don't boast anything close to Olympus Mons. So the next question floats to the surface. What else helped this volcano grow so vast, so quietly? Mars has another secret. Its crust, the outer shell of the planet, is thick, thicker than Earth's. While Earth's crust averages about 30 to 50 kilometers, Mars can stretch beyond 70 kilometers in some regions, especially near the Tharsis volcanic plateau, where Olympus Mons was born. Why does that matter? Because a thicker crust traps heat. Imagine wrapping a hot mug in layers of blankets. The warmth stays longer. On Mars, this insulation allowed molten rock to build pressure beneath the surface, simmering like a slow cooker for millions of years before finding release. And when it did, it didn't just burst once and vanish. It returned. Again, and again, and again. You crouch, running your fingers across a patch of cooled lava, like obsidian lace frozen in mid-flow. Each layer tells a story of a different eruption, like pages in a geological diary. Some flows are 100 million years old, while others are possibly as young as 2 million. That's remarkably recent in cosmic terms. So Olympus Mons didn't erupt all at once. It grew over hundreds of millions of years, patiently spreading its layers like a cake made of stone and fire. And that brings you to another dreamy realization. Earth has something that keeps its volcanoes moving, literally. Tectonic plates. Earth's surface is broken into massive slabs that shift, collide, and slide beneath each other. That movement means lava sources, the hotspots, don't stay in one place. Instead, the crust moves over them. So a volcano erupts for a while, then the plate shifts, and a new volcano forms in a different spot. This is how you get chains of islands like Hawaii. But Mars doesn't dance. Its crust is still, immobile. So once a hotspot appears, it stays directly under the same spot in the crust for eons. That's why Olympus Mons could keep feeding from the same deep reservoir of magma for hundreds of millions of years, growing fatter and fatter, never displaced. You pause, letting the quiet press in around you. Isn't it strange that something so still could create something so large? You look across the Martian horizon. You can't even see the edge of the volcano from where you are. It's like standing in the middle of a desert where the dunes go on forever. It's hard not to wonder, what if Earth's crust didn't move? Would we have our own version of Olympus Mons? A continent crowned by a singular mountain that never gave up on growing. And what if Mars had Earth's crust, instead always shifting, always unsettled? Olympus Mons might never have existed. Sometimes greatness comes not from chaos or change, but from quiet repetition. From gentle gravity, patient lava, and the steady pulse of time. As you begin to rise again, floating upward on the cool breeze of imagination, the Martian wind hums like a lullaby. It carries ancient dust, mineral dreams, and secrets that only Olympus Mons remembers. And next, we'll meet another of those secrets, lava itself. Thick, slow, and unyielding. A liquid that moves like syrup, but sculpts like steel. The mountain has more to share. You drift now above the vast shoulder of Olympus Mons, tracing the whispery edges of ancient lava flows. The surface beneath you is cracked and folded, like an old map, its lines drawn not in ink, but in stone, hardened and stretched by time. Each wrinkle, each fold tells of movement, heat, and pressure, a memory pressed into rock by the slow breath of a planet. You wonder quietly, what does Martian lava feel like? Is it like Earth's fast, glowing rivers of orange and red? Or is it something slower, quieter, more deliberate? Mars answers not with flame, but with silence. And in that hush, you begin to see its secret. Lava on Mars is thicker, more viscous than the flashy, fast basalt flows of Earth's Hawaii. On Earth, lava often gushes and arcs into fountains, racing downhill, pulled by the urgency of gravity and the weight of a wet, heavy world. But Mars has less gravity, and its lava flows act like they're sleepwalking. They move slowly, cautiously, like honey spilled in the cold. Some flows stretch for hundreds of kilometers, curling and overlapping like the pages of a dream left open too long. Imagine it, rivers of molten rock crawling over the plains, taking years, centuries maybe, to come to a rest. And because of that patience, they pile higher, they stack, they thicken. Olympus Mons is believed to be made up of layer upon layer of these kinds of slow lava blankets, each one only a few meters thick, but covering an area the size of a small country. If Olympus Mons is a cake, then lava is its frosting, dark, dense, and slathered on again and again over unimaginable stretches of time. Now think, what shapes this lava as it flows? Why does it fan out across such wide areas instead of forming narrow cones like many volcanoes on Earth? Mars, again, has a quiet answer shield: volcanoes. You see, Olympus Mons is what scientists call a shield volcano. Not tall and jagged like Mount Fuji or Mount Rainier. No, this is a low-slope, broad-shouldered mountain, a gentle rise. Its average slope is only about 5 degrees, so gradual you could walk up it without much strain if you didn't mind doing it for hundreds of kilometers. Shield volcanoes form when lava is runny and spreads out easily before solidifying. But wait, didn't we just say Martian lava is thick. Yes, but here's the secret. Even thick lava, given enough time, distance, and a quiet environment with no earthquakes or storms to interfere, will eventually create wide, sprawling fields. So Mars, patient as it is, lets these flows stretch far and wide. As you wander over the mountain's shoulder, you spot something peculiar: tiny craters. They pepper the lava plains like freckles on skin. These aren't impact craters from space debris. They're pit craters formed when underground lava tunnels collapse. Lava tubes. Yes, even beneath this sleeping volcano. Hollow tunnels stretch like veins through the ground, some dozens of meters across, others, perhaps even big enough for a train to pass through. Some scientists speculate that future Martian explorers might one day take shelter in these very tubes, protected from cosmic radiation and the harsh winds above. Isn't it wonderful? The same lava that shaped a mountain may someday shield human life. Now float with me gently, just above the caldera, the giant hollow at the top of Olympus Mons. It's not one crater, but 6 overlapping ones, each formed from a different eruption phase. Some are over 60 kilometers wide, enough to cradle a small city inside. You drift over them like a balloon, noticing the edges crumble into terraces and the floor lies silent. No smoke, no heat, just the echo of eruptions long gone. One question comes to mind: could Olympus Mons erupt again? The mountain, like all old giants, doesn't say much, but geologists think it might still be dormant, not extinct. Its last lava flow might have been just 2 million years ago, and in cosmic time that's barely a blink. So you imagine it, a future sky over Mars, trembling slightly as heat stirs deep below. Olympus Mons shifting in its sleep, groaning, preparing once again to speak with fire. But not tonight. Tonight it is peaceful. Its lava rests cool and glassy, and you walk across it gently, your footsteps feather-light. You pause and look back at the mountain's curve behind you. It feels alive in its stillness, not just a monument of stone, but a record of patience, of pressure, of slow transformation. And now you wonder, where does that lava come from after all? What's beneath the crust, stirring like soup in a sealed pot? The answer lies deeper. Beneath the mountain, beneath the plains, in the hidden warmth of a planet that, while cold, now still carries an ember inside. Let's go there next. You ease downward now, sinking softly past the rigid crust of Mars, like drifting into the folds of a thick, rust-colored blanket. The ground above grows distant, and below you, well, there's more mystery than map. You're gliding into the Martian mantle, the place where all that lava was born, where ancient heat still hums like a buried drumbeat. The crust of Mars is surprisingly thick, averaging about 50 kilometers, sometimes more. That's much thicker than Earth's oceanic crust, which can be just 5 to 10 kilometers. This thicker crust acts like a lid, keeping the internal heat of Mars sealed away longer, like a pot left simmering with no steam vent. Below this lid is the mantle, a slow-churning zone of rock that doesn't flow like water, but moves over eons, like soft wax squeezing, folding, pressing. You might ask yourself now, how can something as solid as rock move at all? That's the sleepy magic of time and temperature. Heat, pressure, and age soften even the strongest stone. In the mantle, rocks flow like caramel on a very cold day. Not fast, not loud, just enough to cause continents to drift, or on Mars volcanoes to bloom. And bloom Olympus Mons did. Because beneath it lies what scientists believe may be a mantle plume, a column of hot, buoyant material that rises like smoke through the solid mantle, melting the crust above it. Earth has mantle plumes too. Think Hawaii, Iceland, Yellowstone. But on Earth the crust drifts and moves, Continents shift. Plates shuffle across the surface like lazy rafts. But Mars is different. Mars, you see, doesn't have plate tectonics. Its crust is still as sleep. So when a mantle plume bubbles up beneath a spot, say the area we now call Tharsis, it doesn't move. It just keeps heating that same patch again and again over millions of years. Imagine lighting a candle under one point on a sheet of paper, and instead of pulling the paper away, you just keep heating that one point. Eventually, it'll burn through, and that's what Mars did. Over time, that one spot swelled upward, lava spilled out, and Olympus Mons was born. Not in one grand eruption, but through slow layered breathing lava flow upon lava flow, like the soft layering of bed sheets over a sleeping body. That mantle plume beneath Mars may have been active for hundreds of millions of years. And in the absence of plate motion to drag volcanoes away from the source, Olympus Mons had the luxury of growing ever taller, its roots nourished by an endlessly warm well. But the plume didn't only birth Olympus Mons. It shaped the entire Tharsis region, a highland bulge the size of North America, home to three more massive volcanoes, Ascraeus Mons, Pavonis Mons, and Arsia Mons. Together they form a straight line across Mars's midriff, like buttons on a dusty coat. You drift between them, now feeling the subtle rise and fall of the land. It's as if the planet exhaled once long ago and never quite inhaled again. And this, you realize, is what makes Mars so special. Its stillness, its patience, the way it lets one event stretch out over millions of years. Earth is restless. Quakes, continents, oceans rising and falling like a fever dream. But Mars is content to sit still and cook. You wonder now, is that mantle plume still alive? It might be. Though Mars is smaller than Earth, it cools faster. Its core, once molten and mighty, has largely solidified. That's why Mars doesn't have a global magnetic field anymore. Its iron heart has calmed, but perhaps not completely. Seismic data from recent missions hints that Mars' quakes' gentle tremors still happen. Not as violently as Earth's, but often enough to whisper of movement below, enough to suggest that some molten patches still stir, that perhaps beneath Olympus Mons the old heat hasn't fully gone out. And if it hasn't, could there be another eruption one day? A slow resumption of the lava layers. You imagine the mountain waking, not with a roar, but a sigh, its caldera glowing faintly again after a million years of rest. But that's just a maybe. For now, everything is still. And as you float deeper into the planet's warm memory, the rocks around you shimmer with minerals, olivine, pyroxene, feldspar. Each one born in fire, now frozen in time. Some of these minerals, when found in Martian meteorites on Earth, show that they formed at great depths hundreds of kilometers below the surface. And you wonder, how do we know what's inside a planet we've never entered? That's the beauty of it. Science listens to echoes. It watches rocks fall from space. It builds machines that feel the tiniest shivers in the ground. And so we know that beneath Olympus, Mons lies a still warm past, a slow breath, a hidden fire. It's a fire that built a mountain we now understand a little better. But now, maybe you're curious about the air that surrounds it. After all, how does Olympus Mons keep its towering shape without weather to wear it down? Let's rise again, slowly, gently, and meet the Martian sky. As you begin to rise once again, easing upward from the depths of the Martian mantle, it's as if you're emerging from the warm breath of a slumbering planet. The ground releases you gently, and above the sky of Mars welcomes you with a soft, amber hue, almost like looking through dust-tinted glass. And that's exactly what it is, dust everywhere. Mars's atmosphere is thin, fragile even. It barely clings to the planet's surface, stretching only a fraction as high as Earth's. If Earth's atmosphere were a deep ocean, Mars's would be more like a shallow pond. It's composed mostly of carbon dioxide, around 95%, with just wisps of nitrogen and argon. The pressure at the surface is less than 1% of Earth's, too thin to breathe, too light to hold warmth, and too faint to cause the kind of weathering you're used to on Earth. No pounding rainstorms, no howling hurricanes. Mars is more of a whisper than a wind. But even whispers leave traces. Dust storms drift across the plains, soft as sleepwalkers. Sometimes they swell into global events, cloaking the entire planet in a veil of red haze. The dust is incredibly fine, like baby powder, and it clings to everything. It even lifts into the upper atmosphere, carried by weak thermal currents, floating for weeks, maybe longer. Now think about that for a moment. Olympus Mons. This towering mountain, nearly 22 kilometers high, more than twice the height of Everest, rises above much of that thin atmosphere. So high that standing at its summit, if you could, the air pressure would be so low it's practically space. And yet, the mountain remains. On Earth, mountains crumble under the weight of wind, water, frost. Rain seeps into cracks and freezes prying stone apart like gentle fingers over thousands of years. But on Mars, there's no rain, no rivers to carve gullies, no roots of trees to split stone. Erosion, the great sculptor of landscapes, barely exists here. That's one reason Olympus Mons is so tall, so wide, and surprisingly so well preserved. It hasn't just grown, it's been left alone, like a sandcastle on a deserted beach where the tide never comes in. You begin to drift along its massive slopes now. They're incredibly gentle, averaging only 5 degrees in steepness. That's because the lava that built them was very fluid. It spread far before cooling, stacking in layer after layer. It's what geologists call a shield volcano, and Olympus Mons is the most dramatic example in the solar system. Its base sprawls out over 600 kilometers, that's wider than the entire state of Arizona. You could fit dozens of smaller volcanoes inside it and still have room for a picnic. And speaking of picnics, you might be wondering, if someone could hike to the summit of Olympus Mons, what would they see? Well, aside from the view being obscured by the thin air and frequent dust, they'd find a caldera, a massive sunken crater at the peak formed when the volcano collapsed in on itself after eruptions emptied the underlying chamber. Olympus Mons's caldera is not just one, but a complex series of overlapping depressions, like a giant bowl cradling smaller bowls. Each tells a different story, a different moment in the volcano's history. Each one a time when the mountain exhaled and the roof caved in, and then silence. You hover here for a moment, right over that caldera. The Martian wind, if you can call it that, nudges a few particles of rust-colored dust across the rim. There's no sound, no birds, no insects, no footsteps, just silence, deep and endless. And maybe now you're wondering, how long has Olympus Mons looked like this? How long has it waited here untouched? Estimates suggest that the last major lava flow on Olympus Mons occurred about 2 million years ago. That might sound ancient, but in planetary terms, it's recent. Think of it as the mountain's final sigh before a long nap, or maybe just a pause. Some scientists believe it's not entirely extinct, that magma might still lurk deep below, waiting for the perfect moment to rise again. But without tectonic plates, without the dynamic churn of Earth's crust, that moment may never come. Still, Mars holds its breath, and Olympus Mons waits, unweathered, unbroken, massive, and quiet under the faded sun. And what about the sun? It shines here too dimmer than on Earth. From Mars, the sun is about 40% less bright. It casts long shadows, and its warmth barely brushes the surface. But even that faint warmth plays a role. It stirs the thin atmosphere. It powers those dust storms, and it whispers across the surface of Olympus Mons, day after quiet day. As you rise higher past the summit, past the thinning air, into the edge of Mars's sky, you turn back for one last look at the mountain. It stands alone, a sentinel in red stone. And in that stillness, in that silence, you wonder what would Olympus Mons say if it could speak. Maybe nothing at all. Or maybe just this: I waited, I burned, I rose, and now I rest. Now you're drifting gently away from Olympus Mons, that mighty red sentinel, as if caught in the soft pull of a story, still unfolding across a planet that seems asleep, but isn't quite done dreaming. Your gaze travels eastward, where the smooth shield of the mountain gives way to a chain of ancient scars, the Tharsis region, Mars's volcanic heart. Imagine, if you will, a patch of skin on a planet, swollen and uplifted, stretched over centuries like a blister on a grand celestial scale. That's Tharsis. This vast volcanic plateau spans nearly 5,000 kilometers, roughly the width of the continental United States. It bulges out of the Martian crust, a gentle rise created not by plate tectonics, like mountain ranges on Earth, but by the persistent pressure of magma below, a pressure that never found release in just one place. And so it bubbled up in many. Here you find more giants. 3 massive volcanoes line up like sleepy guards, keeping watch: Ascraeus Mons, Pavonis Mons, and Arsia Mons. Each one is a shield volcano like Olympus Mons, wide, gentle, ancient, patient. Ascraeus, the tallest of these 3, rises to about 18 kilometers taller than any mountain on Earth, save Olympus itself. It is so large that from its base you wouldn't see its summit. The curvature of the planet hides it from you. Imagine standing on something so big you can't see it ends. It's like trying to hug a cloud. Each volcano in the Tharsis region was born from magma that welled up over millions of years, lava that flowed not with fury, but with grace. On Earth, volcanoes might burst in explosive fits driven by water and pressure. But Mars is dry. There's little water to turn gas into a sudden outburst. Here the lava simply oozed slow and smooth like honey over a cold plate. And this oozing did something Earth couldn't allow. Without plate tectonics to shift the land underneath, each volcano on Mars stayed rooted in place. Over time, layer after layer built higher and wider. On Earth, a volcano like Hawaii's Mauna Loa is carried off the hotspot as plates move, making way for a new one. But on Mars, the hotspot stayed still. So did the volcano. And it just kept growing. Tharsis is like a diary of the planet's early ambition. A region that tried over and over to reach for the stars, flinging molten pages upward. But here's something even more curious. The Tharsis bulge is so massive, its weight may have tilted the entire planet. Yes, tilted. Imagine Mars spinning like a top. Now imagine placing a thumb on one side and pressing down ever so slightly. The whole balance shifts. Geological evidence suggests that Mars's rotational axis may have realigned due to the sheer mass of the Tharsis Plateau, changing how sunlight strikes the poles, possibly altering climate patterns across the globe. Can a volcano change the weather of an entire planet? On Mars, apparently, yes. Let that thought wander in your mind for a while. What does it feel like knowing that a mountain can move a world? The Tharsis volcanoes haven't erupted in millions of years, but they linger their forms, crisp and preserved. There's no rain to wear them down, no roots to pry them open, just dust, wind, and time. Even their lava flows are still visible from orbit, etched across the surface like ancient calligraphy. As you drift closer to Arsia Mons, the southernmost of the 3, you notice something peculiar. Near its base lie caves, lava tubes, created when the surface of a lava flow hardened, while molten rock continued to flow beneath. Once the lava drained away, these hollow tunnels remained. Some are thought to be hundreds of meters wide and several kilometers long. On Earth, such tubes are rare and beautiful. On Mars, they may be sanctuaries, places shielded from cosmic radiation, from dust storms, from the brutal temperature swings that define Martian life. Some scientists even think these lava tubes could one day house explorers, maybe even settlers. Imagine a future where the first Martian homes are carved into the bones of volcanoes, nestled in tubes formed by fire and preserved by silence. Wouldn't it be something to wake up in a lava tube on Mars, shielded by rock that once flowed like liquid flame, looking out at a horizon the color of rusted dreams? You start to wonder about Mars's volcanism today. Is it really finished, or is it only resting? There are thermal signatures, gas emissions that suggest some volcanic activity might still exist beneath the surface. Maybe not eruptions, but quiet movements, murmurs of heat, soft rearrangements of crust. Mars, it seems, still has a heartbeat. Faint, slow, but present. And with that thought in mind, you hover just a little higher, floating now over the center of the Tharsis bulge. Beneath you, an entire swath of the planet rises like a memory that refused to sink. The volcanoes stretch away in all directions, giants long asleep, but not forgotten. They're not just geological features, they're storytellers. Each one tells of a time when Mars burned with youth, when its core pulsed with energy and its skin rippled with molten light. Now all that remains is their shape, their quietude, their silent testimony. And you wonder if Olympus Mons and the Tharsis volcanoes are so tall, so massive, so untouched. What might they still be hiding beneath their surfaces? Only Mars knows, and it's not ready to tell everything just yet. You drift now from the towering volcanoes of Tharsis to something perhaps even more astonishing, the idea that Mars was once long ago a world of water. It may seem strange here among all this rust-colored dryness to speak of lakes, rivers, and even oceans. But Mars remembers. It holds on to the echoes of its watery past, the way Earth holds on to fossils' evidence, pressed into place by time. Close your eyes for a moment and picture a young Mars warmer, wetter, with blue skies tinged by a hazy atmosphere. Imagine standing at the edge of an ancient shoreline, the waves lapping against volcanic rock. Olympus Mons rising far in the distance, like a lonely island in a silent sea. And now open your eyes again to the vast basin known as Hellas Planitia. It's one of the largest impact craters in the solar system, stretching over 2,300 kilometers wide and plunging more than 7 kilometers deep. If you placed Mount Everest inside, it would vanish beneath the rim. But more than a crater, Hellas may once have been a lake, or even part of a northern ocean. Scientists believe that around 3.8 billion years ago, Mars had a thick enough atmosphere to support liquid water on its surface, an ocean's worth potentially enough to cover the entire planet in a global ocean over 100 meters deep. Where did it go? That question floats through your mind like a leaf down a Martian streambed. There are dry river valleys, outflow channels that snake across the surface, carved not by wind, but by the force of gushing water. Some of these channels are hundreds of kilometers long, meandering and branching like veins on a weathered hand. The water didn't just trickle, it roared. Some theories suggest that these floods were catastrophic, melted from underground ice by volcanic activity or asteroid impacts. Others whisper of a slow disappearance. Evaporation. Atmosphere stripped away by the solar wind when Mars lost its magnetic field. And here's the thread that ties it all together. Mars may have once had the conditions to support life, Not just microbes, but entire ecosystems nestled in warm lakes or tucked into hydrothermal vents near ancient volcanoes. So now, drifting silently through the red planet's thin air, you wonder if life began on Earth in water. Could Mars have had its own Genesis moment? What did the sky look like the first time it rained on Mars? Beneath your feet, dry deltas still fan out across craters like gentle brushstrokes. One of the most famous Jezero crater was chosen as the landing site for the Perseverance rover. That rover searches not just for rocks or minerals, but for signs of ancient biosignatures. Clues that something once lived here, even if only briefly. It's humbling, isn't it? To think of water as a storyteller. Carving, collecting, evaporating. Hiding secrets in clay. Deposits in frozen pockets. Whispering from beneath the surface in the form of briny seeps, which still might exist today, small salty trickles that may wet the surface in fleeting moments before vanishing back into the cold. Now imagine what those ancient Martian seas must have felt like. Imagine floating in one cold but familiar. Above a salmon-colored sky, perhaps thicker than it is now, shading everything in copper and gold. You feel light not because the water holds you up, but because gravity is weaker here. A human on Mars weighs about 38% of their Earth weight. Even the water feels different, like bathing in the memory of a forgotten world. And as the sun sets far smaller and dimmer than the one you know, it casts long shadows across the plains, shadows that fall across the mouths of volcanoes, across dry basins, across questions left unanswered. What would it take to bring that water back? Some dream of terraforming Mars, melting the ice caps, thickening the atmosphere, waking up the climate. But others suggest we listen. First, decode the layers of sediment, the mineral fingerprints left behind, because Mars still holds secrets in its soil. Clay minerals like phyllosilicates only form in the presence of water. We've found them, hidden in craters, tucked into valleys. Silent witnesses to a wetter past. Could Olympus Mons have erupted beside a shallow ocean? Could lava have met water in a hiss of steam, sending minerals spiraling into the air? You begin to wonder. Is it possible the tallest volcano in the solar system once reflected in a shallow Martian sea? The answer waits not in orbit, but underground in the core, samples in the chemistry of stone, in the places where water once lingered before the cold took over. And yet in that cold, Mars has kept its memory. Ice still clings to its poles. Permafrost grips the soil. There is water here even now, if only you know where to look. So you do. You drift closer to one of those ancient lake beds, not to disturb it, but just to listen. There's a hush here, an almost sacred stillness, the kind of quiet that belongs to places that used to be loud. Mars is not just the red planet. It's the planet of absences, of what once was. And in every absence there is still the whisper of presence, the outline of a wave, the hollow of a drop, the ghost of a world that might have looked for a time not so different from our own. You remain there for a moment longer, floating gently over Jezero crater, the basin that once cradled a river delta like a cupped palm. The stone fans out in gentle filigree, like veins of a leaf pressed between the pages of planetary memory. It's quiet now, yes, but there was a time when that silence was broken by water, laughing down channels, pouring sediment and minerals into this ancient Martian lake. But now the winds sweep across the plains, fine grains of dust, whispering secrets across the rim of the caldera. Olympus Mons waits in the distance, serene and silent, but your gaze shifts to the greater Martian neighborhood. It's time to trace the roots of this towering wonder. You drift toward Tharsis, the massive volcanic plateau that holds not just Olympus Mons, but three other volcanoes of nearly equal might, Ascraeus Mons, Pavonis Mons, and Arsia Mons. Together they're known as the Tharsis Montes, and they form a nearly perfect straight line, as though the planet itself once scratched a fiery path across its crust with a smoldering finger. This region is big, really big. The Tharsis Rise is about 5,000 kilometers wide, roughly the width of the entire United States. It covers 1/4 of the Martian surface and rises over 10 kilometers high in some places. The whole thing is like a colossal blister, raised and rounded, swollen with ancient fire. Can a planet ache? You might ask yourself that now, gazing at Tharsis like a wound that never fully healed. It reshaped Mars, literally shifting its crust. Scientists believe that the sheer weight of this volcanic plateau may have tilted the entire planet, causing Mars's spin axis to shift by as much as 20 degrees over time. Pause and think about that for a second. That would be like Earth suddenly moving the North Pole to where London is. Oceans would slosh, climates would change, seasons would go awry. The planet would seem to stumble as though it lost its balance. And here's something to ponder. What could build something so immense? Volcanoes on Mars are shaped differently than those on Earth. They are shield volcanoes formed by lava that's so fluid it spreads out in wide, thin layers, like syrup on a cold plate. But what makes Martian volcanoes so much bigger than Earth's? There are a few secrets Mars holds in its red sleeves. First, gravity. Mars's gravity is only about 38% of Earth's, so lava flows farther and spreads wider before cooling. Second, Mars doesn't have plate tectonics. On Earth, the crust moves, dragging volcanoes away from their source of magma. But on Mars, the crust stays still. That means a volcano like Olympus Mons could erupt again and again in the same spot, growing taller with each gentle exhale of molten rock. There's no conveyor belt beneath Olympus Mons, no shifting of ground, just one mountain building upward for hundreds of millions of years, as patient as a monk stacking stones. And so it grew. Over time, it reached a staggering height of 22 kilometers, with lava flows that stretch over 1,000 kilometers from its base. Its caldera, or summit crater, is 85 kilometers wide, big enough to fit the entire city of Paris and still have space for a cozy park. There are even multiple nested calderas, showing that this giant didn't erupt just once, but again and again, each time collapsing slightly inward, like a breath slowly exhaled. Have you ever wondered what it would be like to stand there? The gravity would feel light, almost playful. You could jump twice as high, run with long gliding strides. But more than that, you'd be standing on the shoulder of a giant. You'd look down from such a height that the curvature of the planet would bow beneath your feet. The sky, thinner than you're used to, would fade from peach to violet to black far too quickly. And beneath your boots, if boots you wore, would be ancient stone layers of basalt built up like the pages of a story you're still trying to read. Some lava flows are remarkably well preserved, because Mars has no rain, no oceans, and only a thin atmosphere. Erosion works slowly here. It's a museum planet in a way. Everything is displayed just as it was, with only dust to dim the shine. And that dust, it isn't just a nuisance, it holds secrets too. Martian dust contains magnetized particles, leftovers from a time when Mars had a global magnetic field. That field vanished billions of years ago, but the dust remembers. It's as if the mountain carries a memory of Mars' once strong heart. You float slowly down Olympus Mons' gentle slope, so gentle, in fact, that if you were walking, you might not realize you were climbing a mountain at all. The average slope is just 5 degrees. You could stroll up it, breathing shallowly in the thin air, and not even feel the strain. As you drift lower, the land spreads out into ancient lava plains. The Tharsis region is pockmarked with lava tubes, giant underground tunnels, carved by molten rivers long since cooled. Some of these tubes could be tens of kilometers long and wide enough to fit entire city blocks. Scientists have even dreamed of turning them into shelters for future astronauts safe from radiation and micrometeorites. But even in their silence, these tubes tell a story. They speak of a time when Mars was molten dynamic expressive, when Olympus Mons and its siblings weren't just dormant stone, but living mountains erupting, flowing, shaping the planet. They tell you that even in the cold, even in the dark, a planet remembers how to create. So you hover there, eyes half closed, wondering what would it be like to hear Olympus Mons erupt. Would it be a thunderous roar, or would the thin atmosphere muffle the sound, making it feel more like a whisper from the depths of time? In your mind's eye, you see it, the slow bloom of fire, the slow-motion ooze of lava, tracing glowing patterns down the mountain's side. And overhead, the sky a quiet canvas painted by dust stars and the arc of two tiny moons. As the Martian winds settle into a hush behind you, you glide away from the Tharsis plateau, leaving Olympus Mons and its slumbering siblings behind. Now your attention turns to the sky, not the far-off stars, but what clings closest to Mars, its tiny moons, Phobos and Deimos. Strange names, aren't they? They mean fear and terror, like twin whispers of some ancient myth. And indeed, in their skittering, irregular shapes and eerie movements, they feel like characters from a dream, shadows flickering just at the edge of understanding. Phobos, the closer and larger of the two orbits, Mars at a breakneck pace. It races across the sky in just 7 hours and 39 minutes, meaning it actually rises in the west and sets in the east, crossing the Martian heavens twice a day. Imagine watching a moon that never lingers, just a gray blur tumbling overhead as if it's late for something. But here's the strange thing about Phobos, it's falling. Every year it creeps about 2 centimeters closer to Mars. That might not sound like much, but give it time, give it 30 to 50 million years, and it may be torn apart by gravity forming a ring around the planet. A ghostly, icy halo made from the bones of a broken moon. Deimos, by contrast, is more shy, slower, farther out, and far less dramatic. It rises in the east like a proper moon and takes 30.3 hours to make one full orbit. Where Phobos is hurried and doomed, Deimos is tranquil, even bashful, trailing across the sky like a lazy ember. And here's the riddle you're beginning to unravel. Where did these moons come from? They're not like Earth's moon, which formed in a fiery collision and was fused from the planet's own mantle. No, Phobos and Deimos are misshapen potato-shaped bodies, only 22 and 12 kilometers wide, respectively. They resemble asteroids more than moons. In fact, scientists believe they may be captured objects, rogue rocks from the asteroid belt, snared by Mars's gravity in some ancient moment of cosmic luck. Picture that for a moment. 2 lonely travelers tumbling through space, gently pulled in and adopted by Mars. They weren't born here. But now they orbit faithfully, even as Phobos spirals inward like a moth too close to flame. Meanwhile, down below, the land tells stories too. Mars is scarred not just by craters, but by time. And one scar in particular is so vast, so deep, it almost splits the planet's skin. This is Valles Marineris, the Grand Canyon of Mars. Only calling it a canyon feels inadequate, almost disrespectful. Valles Marineris stretches over 4,000 kilometers long. That's the width of the United States. It yawns up to 7 kilometers deep and is as much as 200 kilometers wide in places. If you stood at one edge, the far rim might be blurred by the planet's own curvature. It didn't form like Earth's Grand Canyon through slow erosion by water. No, Valles Marineris is a tectonic wound believed to have formed when the Tharsis bulge swelled and stretched the crust like overfilled dough. The planet cracked, split, and collapsed in places, leaving behind a network of chasms, troughs, and fractured cliffs. Can a planet sigh Valles Marineris feels like that, a sigh etched into stone? A moment when Mars stretched too far too fast and left itself aching for the rest of time. You hover above it now, feeling the vertigo of scale. Down below, landslides have frozen mid-motion. Layers of exposed rock ripple like the rings of a tree, each marking an age of geologic memory. Some regions show signs of water, dark streaks suggesting briny flows, perhaps only minutes old when they vanished into vapor. And now a question rises like heat. Could anything live here now? Mars is cold, yes. Its surface temperature hovers around 60 degrees Celsius, but in its sheltered nooks, inside lava tubes, beneath ice caps, or deep within canyons, there may be warmth. There may be hidden lakes beneath the southern pole. Briny ones kept liquid by pressure, and salt like the subglacial lakes of Antarctica. Would life here be microbial, alien quiet, and patient like moss in a desert? No one knows. But the idea lingers in your thoughts like a candle in the dark. What if Phobos once watched something swim beneath a Martian sea? What if Valles Marineris echoed not just with rockfall but with something else? Something soft, organic, impossibly adapted. Perhaps life on Mars is not a question of if, but of when and where. And maybe it isn't extinct, just hiding, sleeping like the volcanoes, waiting. And still as you float over these chasms, the moons wheel above you indifferent. Phobos dips low. Its shadows race across the Martian plains like dark fingers. Deimos hangs high, serene and slow. Between them the sky stretches quiet, painted in copper pink and lavender. The stars shimmer beyond, distant, but unblinking, as if they've always been watching too. In the silence of this alien place, you feel something unexpected familiarity. Because though Mars is different, though its gravity tugs with less strength, and its skies are thin and breathless, it carries echoes of home. A volcano tall enough to kiss the stratosphere. Canyons that could cradle cities. Dust that remembers magnetic fields. Ice that still dreams of melting. And above it all, two moons. Not grand but humble. Not luminous but loyal. A planet's watchful companions. You wonder now, when Phobos falls, will Mars mourn? Or will it simply wait for the ring to form and move on as planets do? And you, ever the sleepy scientist, drift just a little deeper into the mystery. As you continue to float gently above Mars's scarred and silent landscapes, your gaze is drawn outward again, far past the lonely moons and into the vastness of space. But something strange begins to tug at your imagination, not above, but below. Beneath the ochre dust, beneath the ridges and craters and dormant calderas, there lies a question no lander has yet answered. What's inside Mars? You drift downward now like a whisper, sinking through layers of memory. With every imagined meter beneath the surface, the air thins into nothing, but the mystery thickens. Mars has no plate tectonics like Earth, no active magnetic shield to whisper secrets of a molten core. But that doesn't mean the planet is hollow. No Mars has a core, though it beats far more quietly than Earth's. Seismic data from NASA's InSight mission suggests it's about 1,830 kilometers in radius, which is larger than expected. Surprisingly large, in fact. It may be composed of liquid iron nickel and sulfur without a solid inner core, at least not one we've been able to detect. And just think you've never actually seen Mars's inside. Not you, not any human. but you've felt its presence in the stillness of the land. The quiet speaks volumes, doesn't it? Now imagine once this interior may have boiled with fury, churning enough heat to fuel magnetic fields and violent eruptions. Olympus Mons didn't rise alone. It was fed long ago by the heat in Mars's belly. But over billions of years, the planet seems to have settled. Its heart cooled, its tectonic plates never danced. Its dynamo, that magical convective flow that gives Earth a shield of magnetism, fell silent. So Mars became a planet without a heartbeat, or perhaps one in deep hibernation. You wonder what would it take to awaken it again. Could we ever reheat a planet's soul? Could human intervention spark life beneath its crust? Maybe not. Maybe that's like trying to warm a bonfire with a match. But even in stillness, the Martian interior holds tales. In 2021, scientists recorded Marsquake's tremors, soft footfalls in the planet's crust. One quake lasting over 90 minutes whispered of movement down deep, where heat and pressure still coil in hidden rooms. It's as if Mars occasionally stirs in its sleep, so the planet isn't dead, it's dreaming. And now you glide farther east, to a place not often discussed. A strange circular formation known as Utopia Planitia. From high above it looks like a vast shallow bowl, but what you're really looking at is the remnant of an ancient impact over 3,000 kilometers wide. One of the largest impact basins in the solar system. Yet it's what might lie beneath this plane that captures your mind. Radar data hints that Utopia Planitia may be hiding a massive underground reservoir of ice. Imagine that. You imagine what's buried even deeper beneath the permafrost, beneath the basalt. What secrets does the crust conceal? Maybe fossils from when Mars had rivers. Maybe geologic records, frozen snapshots of the planet's ancient magnetic field now lost. Perhaps even hydrothermal vents, like those on Earth where life is thought to have begun. A Martian version of the primordial soup bubbling in the dark. You ask yourself, if we drilled here, what would we hear? Would it be the cracking of ancient stone, the hiss of gas escaping after eons of silence? Or would it be nothing at all, just the dull thud of lifeless pressure, marking time with indifference? Mars doesn't give easy answers. But that's part of the lullaby, isn't it? You drift across the landscape now like a slow balloon. Beneath you, rocks whisper in the language of iron. Dust clings to your mind like forgotten thoughts, and off in the distance you catch a glimpse of something unexpected, a landslide fresh enough to suggest motion. Or a streak dark and narrow running down a slope where sunlight lingers longest. These are called recurring slope lineae, fancy words for what might be briny water leaking during the warmest hours. They appear, vanish, and sometimes reappear. Could they be the fingerprints of modern-day Mars? A fleeting exhale of moisture, could Mars still be speaking? And if so, do we even know how to listen? As your mind loops lazily through these questions, you begin to realize something profound. Mars, this dry, red, seemingly silent planet, is full of movement. Not rapid, not loud, but slow, subtle, like tides within stone, like dreams shifting beneath a blanket. It's not dead, it's just resting. And you curled inside this drifting reverie, find your breath matching the rhythm of its stillness. You float just above the Martian horizon, now trailing a lazy arc along the edge of the Tharsis rise. Below you, Olympus Mons reclines like a slumbering giant, its caldera crowned with the same quiet that blankets the rest of this sleeping planet. But something stirs your curiosity again, not in the sky, not beneath the crust, but in the very air, or what little of it there is. What does it mean to live beneath such a thin, transparent veil? Mars, as you sense now, is not wrapped in the same kind of cozy, protective atmosphere as Earth. Its air is whisper-thin, less than 1% of Earth's atmospheric pressure. Just a gossamer of carbon dioxide with traces of nitrogen and argon barely clinging to the surface like a scarf caught in a breeze. And here's something quietly astonishing. Even though Mars is much smaller than Earth, about half the diameter, in fact its winds can still howl across the plains at over 100 kilometers per hour. Yet they barely ruffle the dust because there are just so few molecules to push. It's like being in a dream where you shout, but nothing comes out. You begin to glide into one of Mars's most dramatic landscapes, the Valle Marineris, a canyon system that stretches over 4,000 kilometers long, about the width of the entire continental United States. It yawns beneath you, as if the planet itself cracked from the strain of holding back its own secrets. Inside this canyon, the walls tower up to 7 kilometers tall, and landslides have carved lazy paths down their faces. Imagine the view, you standing at the base, surrounded by rust-colored cliffs that blot out the sky. The air so thin it makes your breath shallow, your thoughts elongated. You drift past the canyon's layered walls, where bands of sediment resemble the lines on an ancient tree stump. Each layer speaks of a different Martian era. Some bear signs of water clays and sulfates that only form when minerals soak in it for a long, patient time. And so, the canyon becomes a storybook. One page at a time when floods may have gushed through, carving out deep scars in mere weeks. Another, when volcanic activity spread sheets of lava like melted wax over riverbeds, sealing away what came before. You wonder if you touched one of these ancient layers, would it crumble to dust, or would it hum ever so faintly with echoes of what it once held? Now your attention is pulled to the way Mars has changed, not just from a lush planet with water and warmth, but into what it is now. The planet didn't just lose its atmosphere. It bled it out slowly, molecule by molecule. Billions of years ago, solar winds, those invisible high-energy gusts from our sun, tore at Mars's upper atmosphere. Without a protective magnetic field, Mars could do nothing but surrender. Earth's magnetic field, you realize, is like a mother bird's wings shielding its nest. Mars, its wings folded long ago, and with every puff of wind a little more of Mars was stripped away. Can you picture it? Oxygen atoms carried off like dandelion seeds, hydrogen floating into space like a sigh, a great slow exhale that never ends. Even now, Mars loses about 100 grams of atmosphere every second. That may not sound like much, but after 3 billion years, it adds up. It's the kind of long, slow story only a planet could tell. And yet despite this thinning veil, despite this barely there air, Mars still breathes in its own way. You pass over dust devils twirling columns of fine rust-colored particles dancing lazily across the plains. Some of these can rise as tall as Mount Everest, leaving streaks across the surface that last for weeks. They look playful from afar. Spirals of energy in a place thought to be inert. You can't help but smile. Even dust on Mars has a flair for the dramatic. As you continue drifting forward, you start to picture what Earth might feel like if its atmosphere suddenly vanished. Would trees curl inward like frightened animals? Would oceans boil into the void? Would mountains stand taller in the thin blue light? It's strange, isn't it, how easy it is to take an invisible thing like air for granted. And so you imagine a terraformed Mars, an atmosphere returned, thick enough to hug the planet, warm enough to keep water in liquid form. You imagine clouds drifting over Olympus Mons, rain tracing the ribs of Valles Marineris, puddles forming in old craters like ancient memories returning. Could we do it? Could we gift Mars a second chance? Some scientists think it's possible with mirrors in orbit to warm the poles or factories that puff out greenhouse gases to trap heat. But others say it would take hundreds of years and oceans of effort, both literally and figuratively. Mars, after all, is stubborn, patient, unhurried. Still, it's comforting to dream, and while the dream hums gently around you, your gaze turns upward again into the thin air towards the distant sky. The stars shimmer differently here. No twinkle, just clear, sharp light. There's no atmospheric distortion to smudge the stars like on Earth. Just clarity, silence, depth. Mars's atmosphere may be meager, but it offers a view of the universe that is pure and immediate, like the universe wants to be seen in its rawest form. Maybe that's what Mars teaches you to see through thinness, to listen to silence, to recognize presence even in absence. And as you hover there, you can almost feel Mars breathing, not through wind or weather or magnetic fields, but through its silence, its scars, and the soft dust that swirls like dreams across its face. You begin to glide once more, gently rising from the vast canyons and whispering winds of Mars's surface. The horizon curves under you, now delicate and slow, as if the planet is drawing a sleepy breath beneath your feet. And in this high, quiet place, your thoughts drift upward, beyond mountains and atmosphere, toward the invisible tides of Mars' ancient heart. Deep beneath the crust lies the planet's mantle and core structures more mysterious than its crimson plains. You can't see them, but you feel their absence, that curious planetary stillness. On Earth, you would hear the planet murmur through earthquakes, volcanoes, shifting tectonic plates. But Mars, it rests in an almost unbroken slumber. Why it wasn't always this way. Billions of years ago, Mars pulsed with volcanic fire. The lava plains of Tharsis stretched across the surface like a molten ocean, and Olympus Mons rose from the churning deep. Inside the core, once partially liquid and about half the size of Mars itself, swirled with energy. That swirling motion created something vital, a magnetic field, just like Earth's. A magnetic field is a planet's quiet armor, a force field that shields it from the solar wind's invisible teeth. It's not just a line of defense. It's a blanket, a guardian, a whispering hum that says, "I'm alive." But Mars lost its hum. You drift downward again, brushing your consciousness across the frozen crust. In some places, Mars is over 70 kilometers thick, twice Earth's average. Beneath it, the iron core has likely cooled and solidified over time. As the core grew still, so too did the magnetic field fade, like a music box winding down. What would that feel like? To go quiet deep inside until even your own breath forgets how to echo. Without its magnetic field, Mars became vulnerable. The solar wind, traveling at 400 kilometers per second, began stripping away the atmosphere, molecule by molecule, and so the silence of the Martian core rippled outward. An internal hush became an external void. The absence of that magnetic shield explains a lot. It tells you why the planet looks the way it does, scarred, dry open to the cold gaze of space. And it explains why Olympus Mons could grow so high. With no tectonic plates to shuffle its position, the same hotspot fed lava to the same place for millions of years, letting the mountain pile higher and higher. You picture Mars's mantle as a weary artisan working slowly and without interruption. One brushstroke at a time, no shifting of canvases, just one slow, magnificent sculpture rising from a single volcanic pulse. Now your thoughts sink deeper still into the ancient times when the core was active, when Mars had a chance to be more like Earth. Water flowed, air clung, the magnetosphere hummed gently over the poles. But eventually, the engine inside ran out of fuel. What powers a planet's core, you wonder? And what would it take to start it up again? On Earth, heat is generated by radioactive decay of elements like uranium, thorium, and potassium deep within the mantle. These decay processes act like tiny campfires, each one contributing a flicker of warmth. Mars had those too, but likely in smaller quantities. Its smaller size means it also cooled faster, like a cup of tea left on the windowsill compared to a deep kettle that stays hot through the night. There's something bittersweet in that thought, that Mars cooled simply because it was smaller, not because it failed, just because it wasn't quite big enough. And so the planet became geologically quiet. But quiet doesn't mean lifeless. In 2019, a seismometer aboard NASA's InSight lander detected a new kind of sound Marsquakes. Not strong ones, nothing that would topple a Martian boulder, but enough to show the planet still shifts now and then, like someone rolling over in their sleep. You smile at that. Mars isn't dead, it's dreaming. Those Marsquakes helped scientists learn more about the structure of the Martian interior. They found that the core might still be partially molten, a whisper of warmth at the center. Not enough to stir up magnetic fields or tectonic plates, but enough to suggest Mars has a heartbeat, a slow, distant rhythm. And that rhythm pulses beneath you now. You picture it, red-hot iron swirling sluggishly cocooned under kilometers of rock. Ancient heat trapped like a memory. Maybe it glows. Maybe it murmurs in frequencies no ear could catch. Would it feel lonely? You drift higher, watching the Martian surface roll out beneath you like a quiet sea. Craters overlap like ripples in old parchment. Lava plains stretch like dark watercolor. And now, knowing what lies below, every rise and dip seems more intimate. Every fracture is a glimpse into an ancient heartbeat slowed to the point of near silence. And yet somehow it still speaks. Some scientists hope that one day we might reawaken this quiet core. Through clever engineering or natural evolution over millions of years, Mars might become active again. Maybe molten iron could flow once more. Maybe a magnetic field would bloom like a phoenix from iron embers. But until then, Mars lies still. You take one last look beneath the crust, an imagined look, but vivid nonetheless. You picture the mantle like thick honey, slowly convecting in loops that span hundreds of kilometers. You imagine the iron at the center, glowing like a single candle in a cavern. And you think, even in silence, there is power. Mars teaches you that stillness does not mean emptiness, that quiet does not mean forgotten. Its core may no longer roar, but it remembers how to whisper. And maybe it dreams of spinning again. Now you let your thoughts drift from the planet's depths to its skies, that pale pink dome stretched softly overhead like the inside of a seashell. Mars's thin atmosphere isn't thick enough to keep you warm or to sing like Earth's blue vault does when the wind moves through it, but it tells a story. One of lost change and a long, lonely transition from water and weather to a dry, silent stillness. The atmosphere of Mars is mostly carbon dioxide, about 95%, with just a smattering of nitrogen and argon. But it's thin, so thin, that standing on the surface would feel like being 30 kilometers above Earth, higher than even jet planes dare to climb. The air presses down so gently, it barely bothers. And yet there was a time it might have felt different. Billions of years ago, when Olympus Mons first began to rise, that same atmosphere was thicker, warmer, wetter. How do we know? Because the surface remembers. You see it in the ancient riverbeds, winding like dried-up dreams across the Martian highlands. You trace the paths of canyons like valles marineris, too wide and deep to have formed without liquid's patient carving. And you find mineral traces, clays, sulfates, that only form in the presence of water. It's like Mars left behind a photo album in stone, quietly hoping someone would flip through the pages. But what happened to the warmth? Why did Mars let go of its rivers, its lakes, and maybe even its seas? It begins again with the magnetic field. Without it, the solar wind, a stream of charged particles from the sun, had free rein. It slowly peeled away the upper atmosphere, molecule by molecule, until Mars was left with a skeletal version of its former self, like an old book with most of the pages missing. Even now, the sun continues to nibble at what remains. You can imagine it, a constant invisible snowfall of energy brushing against the high reaches of the Martian sky, quiet but relentless. Without a thick atmosphere, Mars lost more than warmth. It also lost its ability to hold on to liquid water. Today, if you poured a glass of water onto the Martian soil, it would either freeze instantly or boil away into nothing. That's how strange the pressure is. Water doesn't settle on Mars, it escapes. But there are clues frozen in time and trapped in shadow. In the polar regions, enormous caps of water ice and dry ice blanket the ground. During winter, these caps can grow to cover 5 million square kilometers, almost the size of the entire United States. And beneath the surface, in special spots, water might still flow. Slowly, quietly, in subterranean aquifers, protected from the bite of space. You imagine those hidden lakes like secret oases beneath a world of silence. No ripples, no wind, just stillness waiting for someone to find them. Is there life there? That question hangs in your mind, like starlight, soft, distant, but always present. Could there be something, anything still living beneath the crust, clinging to the edge of possibility, the way moss clings to a shaded stone? It's one of the reasons we keep sending missions. Rovers, landers, orbiters. We comb the surface like archaeologists of atmosphere, searching for fossils of clouds, hints of breath. And when we find ancient lake beds like Jezero Crater or spot deposits shaped by ancient deltas, it feels like Mars is trying to tell us something. Whispering, I was not always like this. You drift lower now, floating across one of those dry, cracked plains, imagining the air thicker, warmer. You imagine clouds drifting overhead, perhaps not blue, but copper gold, reflecting the Martian soil. You imagine rain slow and sparse but real, a drizzle tapping against a red hill, a puddle forming in a crater. And you imagine what it would sound like. Would Martian rain hiss on the dust? Would the wind whistle between boulders like a flute? Would the sky groan gently with thunder? Maybe. But maybe not anymore. Still, Mars is not done speaking. Even in its current quiet state, it has weather. It breathes in its own way. Every year, the polar ice caps expand and retreat, creating global carbon dioxide cycles. Dust devils, miniature swirling columns of wind, dance across the plains. And sometimes, great planet-wide dust storms rise from the surface, cloaking the entire world in a sepia haze. One of these storms in 2018 silenced NASA's Opportunity rover. You imagine that moment, the little machine blinking its final message, surrounded by swirling dust as the sky darkened and the light faded. So even in thinness, Mars has drama. Even in silence, it remembers the wind. You look out again across this dusky world. The surface appears frozen in time, like a stage waiting for the actors to return. But every crater, every ripple of sand, every whisper of dry air is part of the same long lullaby. A melody of memory and what might have been. Would you want to bring that song back? Some scientists hope to terraform Mars, reshape its atmosphere, warm it up, give it back the gift of water and air. But others wonder if it's better to preserve its quiet dignity, to listen rather than to change. After all, silence is not emptiness. Sometimes it's a kind of presence. And in that silence, you hear something faint but constant, a memory of rain, a whisper of wind, a world that once held oceans in its arms. You close your eyes and let that image settle in. Mars, red and ancient scarred, and still holding within it the echo of rivers and sky. And maybe if you listen closely enough, it still dreams of clouds. Now with your breath slowing, your body growing heavier against the softness beneath you, you gently drift toward the very heart of the mountain itself. Olympus Mons no longer looms, it welcomes. You approach it not as a scientist in a rush, but as a dreamer listening to the slow exhale of a planet that's been waiting a long, long time to tell its story. Imagine touching the rough outer flanks of this ancient volcano, your hand tracing the cool basalt hardened from lava that flowed over 100 million years ago. It's a kind of planetary scar, but not from violence, from creation. Every fold and crevice, every frozen ripple of cooled magma is a signature from an era long past. Volcanoes on Earth are fiery and loud like performers, belting their songs into the sky. Olympus Mons, by contrast, is a gentle giant, a whisperer. It erupts not in short bursts, but in long drawn-out sighs, sometimes over millions of years. And even though it is likely dormant now, its presence radiates the lingering warmth of purpose. You find yourself drawn deeper into its structure, down past the gently sloping caldera, past the overlapping lava flows that cooled into layered fields of memory, past the crumbling rims of ancient eruption cones stacked like delicate teacups inside one another. At the summit you find not one crater, but 6 nested calderas, each marking a separate chapter in the volcano's story. Like tree rings in stone, they stretch across an area up to 60 kilometers wide, large enough to cradle entire cities in their quiet hollows. If you stood there now, you'd see the curvature of Mars itself dipping away at the edges of your vision, the caldera so high it breaks the horizon's grip. And then you go even deeper, not literally, but imaginatively into the workings of the Martian mantle. On Earth, the tectonic plates are in constant motion. They drift, collide, and pull apart, reshaping the crust like a restless sleeper rearranging their sheets. This motion prevents any one volcano from building too tall. But on Mars, the crust stays still. Olympus Mons has no plate boundary to carry it away from its hotspot. Instead, it lounges directly over it for millions and millions of years, drawing heat and magma like a plant soaking in sunshine. That stillness is a kind of permission to grow, to expand, to reach higher than anything else in the solar system dares to dream. Can you picture what it looked like bubbling and flowing during its active years? Lava fountains gently erupting into the sky, arcs of molten rock illuminating the thin atmosphere, settling into slow rivers that crawl outward like golden syrup. No rush, no violence, just the patient rhythm of planetary transformation. And yet even patience has power. Estimates suggest Olympus Mons erupted as recently as 2 million years ago. In geological terms, that's like yesterday. Some scientists even speculate it might erupt again someday. Not with an explosion, but with a slow trickle. A gentle reawakening, like an old poet returning to their pen after a long sleep. You wonder what it would feel like to stand at the base of Olympus Mons when it did. Would the ground hum softly beneath your feet? Would heat whisper through the dust? Would there be a light, faint, distant, glowing like a lantern from the summit? Even in silence, volcanoes have moods, and Olympus Mons has weathered more than magma. Over the years, as Mars changed, so did the winds. They sculpted the flanks of the mountain, rearranged the dust-carved ridges where lava had once flowed smooth. The mountain, though unmoving, is constantly reshaped by time, by climate, by memory itself. The western slopes are steeper, the eastern edges gentler. Why? Because winds from the west have battered this side for eons, stripping it down like a breeze-sanding stone. Even giants are vulnerable to whispers. And then there's the base, the mysterious edge, where Olympus Mons rises not like a spike, but like a swelling wave. It's surrounded by a 6-kilometer-high escarpment, a kind of cliff ring thought to have formed as the volcano's massive weight buckled the crust. The planet, in its quiet way, bowed beneath the burden of this growing mountain. It's as though Mars whispered, "You are heavy with history, but I will hold you." From base to summit, Olympus Mons stretches over 550 kilometers wide. That's roughly the distance from New York City to Washington, D.C. Imagine walking it step by step across cooled lava plains, up gentle slopes so vast you can't even see you're climbing. The gradient is less than 5 degrees a slope, so soft you might forget you're ascending at all. And yet by the time you reach the top, you've climbed over 21 kilometers into the sky. It's not a peak, it's a slow exhalation. A mountain that rises not to challenge, but to invite. And even now, with your mind floating through its corridors of cooled magma and wind-washed stone, there's more to wonder. What lies beneath Olympus Mons? What ancient channels, what sleeping heat, what mysteries of Martian geology are waiting in the silence beneath? Could life ever have thrived here, deep below, protected from the harsh surface? In Earth's own volcanoes, strange extremorphal creatures survive in scalding vents, feeding off minerals and warmth. Could similar organisms hide in the Martian crust? Could Olympus Mons shelter secrets not just of rock, but of biology? You imagine them tiny, resilient. Ancient stowaways in the planet's crust, enduring in pockets of warmth, humming quietly with life, while the surface cools and the winds sweep overhead. And maybe that's the greatest mystery Olympus Mons holds, not just how it grew so tall, but what it might still be holding in its belly of stone. So now you lie still, breathing slow and steady, the image of that volcano glowing behind your eyelids like a lantern in the dusk, tall, patient, enduring, a sleeping monument to time, a giant who has spoken through lava, wind, and silence, and who might one day speak again. You stay there a little longer, your mind curled gently inside the vast embrace of Olympus Mons. The mountain is so large that it defies simple comparison, so tall that it pierces Mars' already thin atmosphere, so wide that if you stood on one side, the other edge would vanish beneath the curve of the planet itself. You begin to feel how the mountain is less a thing and more a presence, like Mars carved a temple to its own volcanic soul. Let yourself drift now to the unseen, to what exists beyond the visible surface. Under the rigid shell of rock and lava, you sense quiet warmth, ghostly remains of geologic fire that once pulsed from the Martian core. The planet's mantle whispers upward, still though slowly now, like a memory fading in a dream. Olympus Mons rests atop a plume, a place where heat once rose steadily through the Martian interior. Unlike Earth's fragmented crust, constantly pulled by tectonic plates, Mars's surface doesn't move, and so that plume sat beneath one spot, feeding the mountain above it for tens of millions of years. Can you picture that heat soft and glowing, like a candle under the floorboards? As the molten material rose, it swelled and spread, releasing its burden through vents and fissures in the Martian crust. Each eruption was like a sigh, slow, unhurried, vast. Even the lava that spilled from Olympus Mons didn't behave like lava on Earth. It flowed more gently, more like thick syrup than explosive fountains. And because of Mars's lower gravity, about 38%, that of Earth's, those flows could spread farther without collapsing. Gravity here doesn't rush things. It allows everything, even lava, to linger. Maybe you're wondering, could Olympus Mons erupt again? It's possible. There are no guarantees, but some scientists believe the mountain is not yet extinct. Dormant, perhaps. Waiting. Like a storyteller who hasn't finished the final chapter. The magma chambers beneath it might still have whispers left to release. A trickle of warmth, a sigh of lava. Would such an eruption change Mars? Not overnight, but it might mark a new breath in the planet's long, sleepy rhythm. It might signal that deep beneath the dust and stillness, the planet still remembers how to move. And now allow yourself to float back outward and upward. Picture the entire mountain from above. The calderas, the broad shield shape the scalloped escarpment, wrapping around it like a stone collar. The faint streaks of dust from wind-blown years. All of it glowing under the orange-pink skies of Mars. It is dusk again. The long Martian shadows stretch across the flanks of Olympus Mons, turning lava ridges into quiet wrinkles. The air is cold, the silence vast. You stand at the edge of the caldera and watch two moons pass overhead, Phobos and Deimos, tiny and swift, always running somewhere. But Olympus Mons never runs. It waits, it watches. Even if no human has ever walked its face, you can sense your own reflection there. The curiosity, the wonder, the longing to touch something bigger than yourself. That's what makes Olympus Mons not just a volcano, but a mirror, a monument to cosmic patience and silent growth. And it hums with questions. What did Mars look like when Olympus Mons was still young? Did it rain? Were there rivers? Did life peer up at the mountain from lower ground, wondering what fire painted its sky, and if someday a rover or astronaut makes the climb, if boots or wheels someday reach that summit? What secrets will the mountain share? Will it whisper about the planets that passed overhead as it grew? About the meteorites that grazed its flanks? About the winds that carved its sides into rippling patterns? Will it remember every pebble, every grain of Martian dust that once swirled around its caldera rim? Maybe. Or maybe it will simply stand still, as it always has, while others tell its story. And that in the end is what you carry with you now, the story. The image of a mountain too vast to see all at once, too ancient to know completely, and yet so gentle that it lets you imagine you've walked its length in a single sleepy night. Let that image settle into your breathing. Let it nest in the quiet corners of your thoughts. Olympus Mons, the tallest volcano in the solar system, not shouting its greatness, but humming it like a lullaby sung by the red planet to the stars. The winds on Mars fall silent as night deepens. You lie there, your breath now, matching the rhythm of the stars, slow, unhurried, wrapped in the hush of planetary stillness. The memory of Olympus Mons softens. No longer towering, it becomes a silhouette, a shadow at the edge of sleep. You can still feel the faint warmth of ancient lava beneath your fingertips, like the last glow of a hearth before it dims to embers. Your body relaxes heavier, now the gravity of rest pulling you gently down. Let go of questions for now. The mountain is content to hold its answers a little longer. The Martian dust drifts softly across your thoughts. The sky fades into velvet. You are small, but the universe does not mind. It holds you just the same, like Olympus Mons held the stars overhead for eons, steadfast, patient, quiet. If you've enjoyed this journey, I'd be quietly grateful if you'd give this video a like or tap that subscribe button for more peaceful explorations with the Sleepy Scientist. It helps more than you might imagine. And before you drift off, I'd still love to know, where in the world are you listening? From what time it is there? Leave a comment if you're feeling cozy enough to share. It's always a quiet joy to see this sleepy little community ripple across time zones and continents. Good night. Sweet dreams.